Hello, today we're going to be learning about relations and functions. So we're going to do a bunch of vocabulary to set ourselves up well for this unit. So after we learn about a couple vocabulary words, we're going to pause and go down below and try to answer a couple of questions based off of those new terms. So the first two new terms are going to be relation and function. So a relation is going to be a set of ordered pairs. Going to be a set of ordered pairs. So you'll have an input, an output, an independent, and a dependent value. It's basically any set of points or any graph that has an x and a y. A function, though, is going to be a relation in which each input has exactly one output. So a relation in which each input has exactly one output. So what that means is your input is going to be your x values. Your output is going to be your y values. So for each x, there's only one y value, meaning there are no repeated x values. So if you ever have a table where there's two x values with different y values, that is not going to be a function. You're supposed to be able to plug one thing in and get exactly one thing out. Visually, if you have a graph, the way that looks is it has to pass the vertical line test. Meaning if you have a graph with some sort of function, you should be able to draw a vertical line in such a way that it only touches the function in exactly one spot. Sometimes you'll have a graph, and when you draw a vertical line through the graph, it might touch the graph in two spots. That would mean it is not a function. It would fail the vertical line test. So what we're going to do is we're going to, based off of the definition of relation and function, we're going to fill out those two parts in these first four examples. So looking at this, the first question is it a relation? And so anything that has an input or an output or an x and a y or a mapping is going to be a relation. So everything here is a relation because it relates an x to a y value. So for the function, as a reminder, we cannot have any repeated x values. So looking at our first one, notice how -2 takes you to two different values. This would be a repeated x value. And if you wanted to write yourself a note here as to why it's not a function, that's totally fine. The next one, if we draw vertical lines, they only ever touch the graph in exactly one spot, even when it gets kind of close there. So yes, this is a function because it passes the vertical line test. The next one, you look for your x values 1, 3, 5, 7. There are no repeats there, so yes, this is a function. And then for the last one, our x values are 2, 3, 3, and 2. And for those x values, you notice we have two 2's and two 3's. So no, this is not a function because there are once again repeated x values. So those are our first two new terms. Now we're going to go back up and we're going to talk about domain and range. So these are going to come back in all of your algebra 2s, your pre-calculus. Domain and range is talked about all of the time. So your domain here is the set of your inputs. Domain is your inputs. Those are going to be your x values. Your range then is going to be your outputs. So the domain is your x values, it's your inputs, your range is your outputs. That would be your y values. For both your domain and range, you are going to want to list your domain and range from least to greatest. No matter what order they're listed in the original graph or table or mapping, you always want to list your domain and your range from least to greatest. Another thing that might help is normally your points are listed as x, comma, y. They go alphabetically. Your domain is going to be your x values and your range is going to be your y values. If you think about the D for domain and R for range, it also goes alphabetically. So that helps with domain being the x and range being your y. Let's go ahead and take a look at these ones. So for our first example, our domain, as a reminder, is going to be our x value. Looking at our mapping, this is going to take our x values and relate them to our y values. So for our mapping, our domain is going to be these three numbers in here. We're going to do this in set notation because it is specific separate points here. So the least of these numbers over here is -2, and then 3, and then 4. Your range then, if your domain was your x, your range is going to be your y values. So looking at these, we're going to list the y values from least to greatest. So we're going to start with -3, and then 6, and then 9. Let's come back to the graph here at the very end. Let's move on to the table here. So your x values, these ones right here are your domain. Your y values are your range. So we're going to list them from least to greatest. So we have 1, 3, 5, and 7. Your range values, notice how there's a couple repeats here. So first of all, let's start off with the lowest number. It's 2. The next number would become 4, and then 5 after that. Let's make a note here that there are no repeats in your range. This is really asking like what numbers could you possibly get out for y? So you're saying you might get a 2, a 4, or a 5 out for y. It would be kind of weird to say you'll get a 2, a 4, a 4, or a 5 out. You've already kind of listed that. So you don't list any repeats because it's just the possible answers for x and possible answers for y. So for this one, notice how your x values aren't all lumped together for this one. So you're going to have to be careful. Our x values are the 2, 3, 3, and 2. So the least of those values is 2, and then it comes the 3. Once again, you don't want repeats. So what you're saying here for your domain is, I got x values of either 2 or 3. Your range is the y values then. So looking at all of those y values, the lowest one I see is -2. And then I see another -2, but I'm not going to write it. And then I see a 1. That comes next. For your domain, for this next one, your x values, this one, if it were separate points, you could pull separate points off your graph. This one, the x values go left and right for forever. So you have two options. You can say it's all real numbers, or you can say all the way on the left is -infinity and all the way on the right is positive infinity. Your range is your y values. It goes down and up for forever. So you can say that's all real numbers, or down would be -infinity and up would be positive infinity. For these two, we are going to spend another whole day on graphs. So tonight you'll see all of the different points and not so many of the graphs. So we'll come back to those graphs another time. Let's go back up now and take a look at two new terms here. So we're looking at the domain of your function. It's either going to be continuous if it includes all real numbers, which means on a graph, you actually have to see a line with arrows on both ways. That's the only way we can see it's continuous, is if you actually have a line drawn on your graph. If it's not continuous, it's going to be something called discrete. That's going to be separate points here. So you don't see a continuous line connecting them. If you see separate points, that's called discrete. So if you're ever given a table or a mapping, those are going to be discrete because when you graph them, they're just separate points. The only time you can say continuous is if you see a graph with the line drawn in. So looking at these ones, discrete or continuous. This first one here, we're going to say this is discrete because you have separate points. It's a mapping, so it's just those set of points and that's it. The next one, you see the graph, you see the line drawn. This is continuous because I could actually get to all of the points on my graph by tracing the line. It's a continuous line. This next one is a table of values. This is discrete because it's just a separate points here. Same with the next one. There is no graph with the line shown, so these are just 4 discrete separate points. And our last new vocabulary word is going to be something called one-to-one. So a function is going to be one-to-one if no two elements of the domain map to the same element on the range. What that means is there's no repeated x values or y values. You can't have any repeated x values. You also can't have any repeated y values. So it has to pass the vertical and horizontal line test. It's like one-upping a function. So if it's a function, it has to pass the vertical line test. One-to-ones have to pass both. So looking at the first one, you notice there are repeated x values and repeated y values, so it is not one-to-one. The next one passed the vertical line test, so there were no repeated x values. So if you look at the horizontal line test, it's also going to pass the horizontal line test. So yes, that is one-to-one. The next one had no repeated x values, but there were repeated y values. So no, this is not one-to-one. And the next one fails because there are both repeated x values and y values. So no, that's not going to be one-to-one. So with that in mind, we have all of these new different terms: function and relation, domain and range, discrete or continuous, and one-to-one. What I'd like you to do is pause the video and try the next couple examples. And once you try examples 1 and 2 and all of the parts, then come back to the video to hear the explanation of them. Okay, so pause the video now, try it on your own, and then come back. Let's go ahead and take a look at number 1. Your domain for number 1 is the set of all x values in set notation from least to greatest. So squiggle 1, 2, 3, 4, 5. Your range is your set of all your y values from least to greatest with no repeats, so 11, 12, and 13. For B, your domain is your x values. So if it helps, your x values are going to be wherever your points are looking at your x values. So -4, -2, -1, and 3. And your range is your y values. So you can look at -2, 0, 1, and 2. Now, if you didn't like that, honestly, there's nothing wrong with taking and writing out your points: -4, -2, -2, 1, -2, 2, -1, 0, 3, 1, and 3, -2, and just doing your domain and range from there. You'll get the same exact answer. For the bottom parts, we're looking for, are these functions, are they discrete or continuous? Are they one-to-one? So this one is a function because there's no repeated x values. It is discrete because it's a set of points. And it's one-to-one because there's also no repeated y values. This one is not a function for B because there's repeated x values, which also rules out one-to-one. And it's discrete because it's a mapping here instead of a graph with a line drawn. C is a function. It passes the vertical line test, and you see that line drawn here, which makes it continuous. And it's one-to-one because it also passes the horizontal line test. For D, it's a function because there are no repeated x values. It's discrete because it's a set of points. It is not one-to-one because there are repeated y values. Your domain is 1, 2, 3, 4, 5, and your range is 10, 11, and 17. Thank you very much for listening. I hope this helped.